Hi, good evening to all. Tell me, how was your weekend? And one thing, am I audible to all? I'm reading the chats. Tell me, am I audible to all? I'm looking at the chats. Am I visual and audible to all? I'm looking at the chats. Okay, build. Wealth making. Cool. Okay. Yep, we know on which path we are going. We know very well, right? Because the agenda of this whole series is that because after this series, you want to be stucking in the coding questions which has been asked in any company, right? So that was our agenda, and for that purpose what we were doing is that we are planning a whole 150 days lead code series, right? So now in the math part, previously what we have done is, previously we have already, previously we have solved around 5 questions. Today we will solve question number 6 as day 6, right? So in math series, in the math sequence, because all these topics will cover later, right? We'll cover like arrays will cover, arrays of frequency counter will cover. But as you know what's going on, which is math going on. And trust me, it's super important to form basic logics. But before we move, do one thing, share this live with your friends as well, by which they can also get benefit of it. Okay, so now today's question is, we'll go and we'll see what is the question of today's live. So I'll go to the lead code, and here I'll search one question which is count primes. This can sound easy to you, but trust me, it's a very, very important question. It has been asked, I guess, in all top companies, even Google, Amazon, Bloomberg, Facebook, and many other companies. But why? What is the reason? You can see the acceptance rate of it, which is 34.3% only. And some people were asking what will be the timing of the live. Every day I come live at 6:15 only, 6:15 every day. Okay, so now here count primes, you can see the acceptance rate of this problem, which is 34.3% only. Definitely there is some reason, right? There is some reason by which this has a very lower acceptance. So we'll see, we'll read the problem, we'll understand that what has been asked and why this acceptance rate is very lower. Okay, and trust me, it's a super important question to form a logic as well. And this question has been repeatedly asked in multiple companies. So maybe you'll be a lucky one who can get the same question in your interview. Okay, and during this journey, when I'll see that you are enough, capable now for interview purposes, I'll release some tips for you, how you can apply in other companies, how you can get selected. Right. So these things will come later. But as of now, what I want is that you should focus on the problem solving. Right. Now read the problem. They have told that given an integer n, return the number of primes that are strictly less than n. So which means, for example, there we have n which is 10. So I need to tell all how many prime numbers will come between 1 to 10. Okay, between, not included. So here the prime numbers are 2, 3, 5, and 7. Right. So we'll go to the whiteboard, and we'll understand how we can solve this problem. So I'll take an empty slide, and the color, which color you like? Tell me. I should. In color, I want today is yellow. I don't know why, but I like it. Okay. So now here the question is count primes. Okay. Count primes. Count primes. So first we need to understand what is prime. I know everybody already knows, but I'll take hardly 1 minute or 30 seconds. Prime are that number which is divisible by 1 or itself, right? So what we want to calculate is that we want to calculate the number of prime numbers between 1 to n, right? So what our problem is? Our problem is we want to calculate total number of primes, right? Total number of primes from where? From where? Tell me. From 1 to n, right? Or the n is, we are not including n, it's excluded, right? So for example, we had 10. So how many prime numbers are there? There are 2, 3, 5, and 7. So total 4 primes are there. So output should be 4. What should be output? Or UTPUT should be 4. Why? Because there are 4 prime only. So that was the problem statement, that we understand, right? But now Now, yeah, other people are not interacting. I want little bit interaction here. I want little bit energy. Because the class shouldn't be boring. We should have fun, a lot of fun, right? So now here, how we can do this, right? How we can do this? So basic approach can be one thing. That what I will do is that I will pass 1 to n numbers. Okay, 1 to n, basically n minus 1 because n is not included. So I'll pass 1 to n number, and I will have something which can tell me like this is a prime or not. And if that something, just assume like there is a one person. Okay, there is a one person, I don't know who. Give any name to yourself. So let's say there is a one person. Yeah, this person doesn't sound very beautiful, but okay, fine. So now what I will do is that I'll pass number 1 to n. So let's say I'll not 1 to n, actually 1 we know that it won't be a prime number, right? And 2 can also not be part on this, because if the n is 2 and n is excluded, which means we are talking about 1 and less than 1. So in this case what we'll check is that we'll check from the 3 to n minus 1, right? That's what the problem statement is. So now let's say I passed here 3 and this person is telling like true. If this person is telling like true, so which means we can count plus 1, right? So let's say and again if n is equals to or 2, only then we will say like there is no prime. Why? Because n is excluded. But now if let's say there was 10, so what we were doing is we were running from 2 to 9, right? So we have passed 2 to this person, and this person is saying 2 and saying like yes. So what we'll do, we will have a variable, let's say count, and that we will increase. Again, we from the loop we pass the another number which is 3. This person said like 3 is a prime or not, so this person said like true. So we'll do again count plus plus. Again we have passed 4, this person says false, we won't do anything. Again we passed another number which was 5, so this person said like it's prime number, we said true. Again it will pass 6 because we are running a loop from 2 to n minus 1. So every time we will pass one particular number to a particular person, and that person will identify a particular number is prime or not. If that is prime, then do count plus plus. That can be a basic logic. That can be a basic logic. But you know what the problem here? The problem here in the problem statement is that because that's why the acceptance rate is very low. Because here is a problem. For very larger input, you cannot work with this much of time complexity. Okay, because anyhow we are creating a function because this person cannot tell anything, right? This would be a method. So now this method will implement a logic to check a prime, and you're calling that method inside a particular loop. You're getting the logic. You will call that person inside where? Inside a loop, right? In that case, what will happen is, it will take a lot of time. If n is very large, you will see a problem, time limit exceeded, which means that we need to figure out something optimized. And this is the only reason, that's why this problem has been asked in multiple companies. Why is that? Because here's a trick. Everybody will think about this basic logic, they'll read the problem, they'll understand, they'll figure out this solution, but this solution won't work. That will give you a problem of time limit exceed. So what is the another solution, right? So problem solution number 1 will not work. It will work for some cases, but for other cases when the n is very large, we will get a problem which is time limit exceeded. So now what can be the another solution? What can be another logic? Another logic is that we need to speed up our solution. We need to speed up our solution. So whenever you want to do some kind of something like you want that program should execute faster, either you can go for the bitwise operator where you are working with bits, or either you can have something boolean. So what I'll do is that I'll create a boolean array. Okay, I'll create a boolean array. I'll take a pen to make you understand. I'll create a boolean array. A boolean array where what I will do is that I will I'll create a boolean array till n. Okay, so for example we had n is equals to 10. So I will create a boolean array where every value will flow automatically to true. Okay, let's say everything is true automatically. So I'm assuming this is 0 index, 1 index, again true. Okay, again true until where? Till ninth index, right? Because the till 10th index, because we are creating till n. Okay, so now because last one is exclude, so till 9 index we'll do array of 10 size, right? So at the end we will have, I'm creating an array, okay, of n size, and where automatically I'm filling all the values to true. I'm assuming all the numbers are prime. Okay, so last index will be 9. What I will do is that there is a theorem, one algorithm which says like if you want to figure out a particular number is prime or not. So do one thing in this array, mark all the numbers which are not prime, and the remaining number will be, you can count the numbers like which is prime, right? So now what I can do is that if a particular number, the logic is if a particular number has multiples. Okay, has multiples means something and divide it, right? Or we can found another number by multiplying it. If a particular number has multiples other than what, other than 1 in itself, then we can say that number is not a prime, right? For example, we say 4, so 4 has multiple of 2. We can do 2 multiply by 2. 2 is a prime, but multiply, if we talk about the 4, 4 is not a prime number. Why? Because it has multiples. If I talk about 6, so 2 multiply by 3, it has other multiples than 1 and 6, right? It's not a prime. So the logic can be here the understanding, okay, that all the tough things are here only. So listen carefully. What we have to do is that we can have a array where all the value are assumed to be prime. Again, what we will do is that we will check like how many numbers have multiples. All those numbers have multiples, we'll make them false. So the remaining values will be true only, and these are the primes. So for example, if I don't have to check with this as well. Why is that? Because 0 and 1 are not prime. So what I'll check from the 2 itself. Okay, so now I'll come to the 2 and I'll see that does 2 have any multiples? So I'll check, and again I'll mark all the multiple of 2 as false. All the multiple of 2 as false. So let's say here was another true. Okay, and that index was 4. So here's one 2. Okay, I will not change it, but I will change all the multiples of 2 to false. So let's say 2 again 4 will be false. If all the multiples of 2 will be false. Okay, so now this will become false. This will become false. And another who will become false? Who will become false? Another value. The value at the 6th index will be false. The value at the 8th index will be false. Yes or no? So now we have the false value at 4th index, at 6th index, at 8th index. Then we'll take another value which is 3. I'll mark all the multiples of 3 to false because those numbers have 3 as a multiple. Yes or no? And prime numbers cannot have multiples. So now all the multiples of 3 will be marked as false. So now again after 3, the multiple of 3 can be 6, which is already false, so we will not change it. Again the 9 becomes false. 9 becomes false. Yes or no? Now how many times we have to do this? Again here is a logic, here is a one thing. You need to check only the square root of n. Okay, because every non-prime number, remember there is a one algorithm, there is a one logic. Every prime number, non-prime number, sorry, every non-prime number, listen this very carefully. Okay, this is super important. Every non-prime number has multiple less than or equals to the root n. Every non-prime number has multiple less than or equals to the root n. Okay, so here is a mathematical logic. So for example, if you have n equals to, let's say I'm talking about, which is 16. Okay, so the number can be like, the multiple will be, less than or equals to, let's say 4, right? Because the root of 16 is 4. So here can be multiple like 2 and 4. So every non-prime number has multiple less than or equals to root of n. So that is a logic. So now I'll figure out a logic. So the logic is that what we will have is that we have already thought about it, like how we can do. We will have a Boolean array. We will fill all the values with true. Again, we'll check the multiple. If multiple exists, we'll mark them false. At the end, the number of true value will be the total count of time. Makes sense to you? What we'll do is that, simple understanding now, what a Boolean array, then mark all non-prime number to false, non-prime numbers to false, and then what? Then calculate prime numbers, because all the true numbers are prime numbers in the array itself. Yes or no? And that will be your answer. At the end we will discuss the time complexity of it also, because trust me, here's the amazing logic behind the time complexity of it. And that's why this problem is super important and has been asked in a lot of companies, all the top companies almost. Okay, so now we'll go to the computer screen, in the LeetCode screen, and we'll do the code here. We'll do the code here. I will understand. After that, we'll once again dry run it. Okay, because trust me, this problem is still not super easy. But again, if you will put a focus, you will get to know like how the solution is working. Okay, how the solution is working. So here, what we will assuming that for counting, we can have a count variable. Yes or no? In this, we will count all the prime numbers. Again, we will have a boolean. We will have a boolean array. Let's say the name of this. I'll give you check. Okay, I'll give this name to check. And I want to create n size array, right? So new boolean, I'll create an n size array, and the size will be n. The size will be n. Region you know, right? 0 to n minus 1 automatically, because indexing will start from 0 and the last will have n minus 1 index. Yes or no? So now here, what we were trying to do is that automatically we will fill all the values to true. So how you can fill? Either you can apply a loop or you can use a arrays.fill method. So what arrays.fill do is that it will, it will update all the values of the array. So now the array name is check, and what I want to fill at everywhere, which is true, and keep asking the out. Okay, because I'm doing this live for helping you guys. I want that, I want that you should have, I want that you should have a very good understanding, and only then it's a possible, right? Because if you will ask a lot of questions to me, if you have any doubt, then keep asking. Okay, because right now I'm seeing the chats, I can reply, but later I don't know. Okay, so now here, what was the plan is that I want to check what from where till where we want to check the the multiples. What I mentioned is that every non-prime number has multiple less than or equals to the root of n. Yes or no? The root of n. So here what I'll do is that I'll write int I equals to from 2, because 0 and 1 are not a prime number. So again, the I should be less than math dot sqrt, means square root of n. Every number, every non-prime number has multiple less than or equal to the square root of that number, right? That is the algorithm. Okay, so now here what I'll do is that every time I'll do I plus plus again. And trust me, your problem solving is something where people get frustrated. They think to break their laptops. They think like the problem solving is not for them, but it takes a lot of time in understanding. And the way to understand it, first listen to me very carefully, then dry run the solution on the pen and paper, put a lot of inputs and see how these things are working. When you will solve a lot of problems with me, and you will try by yourself as well. Probably with slowly with time, you will be able to form logic by yourself as well. So don't worry, but keep following the things, because I planned this very thoroughly from a lot of experience. So and again, the multiples I want to check from the number itself. Like let's say the multiples will be, if I talk about the 2, so I'll check from the 4, like 4 6, because 2 was itself a number, right? That's a prime number. So again, I want to mark false all the multiples of 2, not the 2, right? So I'm assuming j equals to, I will start from the multiplication of it, because if let's say I is 2, so I want to check the multiple from the 4, not from the 2, right? If this is 3, I will check the multiple from the 9, not from the 3, right? Because multiples are possible after that only. So now here again j is less than, till where j is less than n, and again every time I want to check the multiple, which means the value of j will be increased by I, not by 1, because after 2 I want to check for 4, after 4 I want to check for 6, after 6 I want to check for 8. But what's happening, every time the value of j increasing by 2, which means whatever the value of I, we are increasing by that, right? So j plus is equals to I, means j is equals to j plus I. Yes or no? J plus I. So now this was the logic. Now here what I will do is that I will do one thing, and before that, before performing this, we have to check like a particular number is a prime or not in our prime array or not. So for that we haven't checked. I'll do is one thing, like if check, okay, if that number is already true, means already has been marked prime in our check array, only then we'll mark all the multiples of it to false. Okay, so now here we go, and keep asking doubt. Yeah, problem solving, trust me, is not so easy. It's not for everybody. It's for only geniuses. That all the genius people can understand, but at starting everybody struggles. Okay, so now again, if that number was already available true in the boolean array, which means that there was a prime number, so again we will mark all the multiple of that number to false, because other numbers cannot be prime if they have multiple, right? So now here what I'll do is that check, and on that particular jth place, what I'll do is that I'll mark false. I'll dry run it for you. Okay, I'll dry run after the writing the solution, so you'll get more clarity on it after this. Okay, so now what has happened is that we have marked all the multiples of every number to false, and at the end what we will do is, at the end, now in the array all the prime numbers are true, all the non-prime numbers are false. So I want to count them. How I can do this? I don't have to check from 0 and 1. I will check from the 2 itself. So I'll start I equals to 2, right? Because 0 and 1 are not prime, and again I is less than till n, yes or no? Again I plus plus, and what I will do is that if in that check array it was true, right? It was true, which means that was a prime. Okay, all the prime numbers are true only in the boolean array, and remaining are false. We have marked all the multiples to false. So in that time we'll do count plus plus. We'll do count plus plus. And can somebody tell me what will be the time complexity of it, of this program? Any of you? Just take a random guess. Okay, now at the end we can return the count. Take the random guess. Yeah, I can't see the faces which of the people who are every day they were present. Please write down. I'm missing you guys. Okay, so now I'll run this, and I'll see like how is this working. Okay, I'll see how is this working. So now it's working fine. I'll submit this, and then I will do a dry run for it, and you'll get to know. No Sanket, it's not an square. Okay, probably it's good. Yeah, probably it's good, because if you will come to the 2 millisecond, somebody what they had done is that there are 64 test cases, and I guess whatever the test cases are, they figure out some numbers and they have hard coded it by if and else. So what they are doing is that for every particular input they're passing some kind of output. This is not the right approach to do things. Okay, not the right approach to do things. We have applied a good logic. Okay, this is not the right approach. Other you can try from the bitwise operator, but a lot of people struggle in that. That's why I'm doing this solution, because it's an optimized one and good. So now I'll do a dry run of this. How is this working? Then we will move ahead. Okay, then we will move ahead. So now again what will happen is that, let's say we have n equals to 10. So now you will have an array of 10 size, 0 to n 9 index, right? All the value of that array will be filled by true, yes or no? 0 to 9 index. Again, because we know that if a particular number is not a prime, then the multiple will exist less than or equal to the root of n. That's why we are doing this logic, right? This one, because I want to check till only when the I is less than, I can check till n also, because that will take a lot of time. It is fine for us to check a root n, right? Now again, if that particular number, for example, we had 10, okay, and we are starting from 2 to 10, the square root of 10 probably will be 3 point something. So now here what will happen, I will start from 2. Again I'll check 2 at the second index, that was true in the array, because all the value are filled with true only, right? So in check array, at the 2th index will get true. So this if will execute. Now we will come here. Now again j will be 4, because I was 2, so 2 multiplied by 2 becomes 4. So now j is 4. Imagine this, huh? Otherwise you write it on the paper. So now this j is 4. Again, is 4 less than 10? Is 4 less than 10? Yes. Now again we'll come here. We'll do what? We'll do false at the place of 4, because 4 is not a prime number. So now at the 4th index we have false. Again the value of j will be increased by 2, because I was 2. So now the j is what? J is 6. So now again 6 less than 10. Yes, it is less than 10. So in the check array at the 6th index we mark false. Again the value of j will be increased by 2. This becomes 8. Is 8 less than 10? Yes, it is. So at the 8th index we'll mark false. Again, what will happen? The value of j will be increased by 2. Again, is 10 less than 10? No. Which means that this loop will be terminated. We'll come to the again this, the value of I will be increased by 1. Now this becomes 3. Is 3 less than the square root of 10? Yes, that is less than. Again, we'll come here. Is 3 marked as prime in the Boolean array? Yes. On the third index, it was true. So now we'll come here. The value of j will become 9. 3 multiplied by 3 becomes 9. Yes or no? So now what will happen is 9 less than 10? Yes, we'll mark that to false. At the ninth index, we'll mark to false. Yes or no? And now what will happen? Again, because the value of I will be increased by 1, now which is 4, but 4 is not less than the square root of 10. Yes or no? We will terminate this loop as well. We'll come here. Now the value of true are available at the second index, because we are not starting from 0 and 1, are available on the second index, on the third index, on the fifth index, because 4 was become false, 6 was become false, 9 was become false, 8 was become false. So what are true values? At the index of 2, at the index of 3, at the index of 5, and at the index of 7. So now we have the number of primes. Okay, so what will be the time complexity of this? What will be the time complexity of this? You know, this loop will be working till the square root of what? Till the square root of n. Yes or no? So this is a log square root n for this, right? Square root of n. Again, this will work. This will work what? Till again, this will be the, the every time what's happening is that we are starting from the square root. So now what will happen? You will have the time complexity of, in the worst case scenario, I'm assuming. So you will have a time comp for this square root of n. Again, this is a square root of n. So you can have a time complexity of n log n. You'll see this. Why log n? Because this will have a log n. Sorry, this will have a n. This will have a n. Yes or no? And for this square root of n multiplied by square root of n. Right? So that will not be a complete n square. Okay, n plus square root of n square root of n. So now that will be a time complexity for you. I guess, and again, to understand this problem, this solution very carefully, remember to do one thing. Trust me, this problem is not easy and not for everybody. A lot of things are there, but if you will do a dry run, if you will hear me very properly, you'll get to know, you'll understand how all the solution has been designed. I hope you enjoyed this here. I hope you enjoyed this. And again, this problem is super important. Okay, super important. So if you are getting trouble, watch this video again and again, and do dry run by yourself. Pass different value of n. Tell me, as of now, is this clear to all? As of now, is this clear to all? You're getting the logic? The simple logic is, the simple logic is that we'll create a Boolean array, right? And in that, previously we'll mark everything true. And again, in the second round, what we'll do, we will mark all the multiples less than or equals to the square root of n to false. So now the remaining true value will be prime values. We'll count from here. Okay, Sanket. Okay. The others are not interacting. But okay, it's fine. I wish you all the best. And I know that if you will keep following this journey, one day you'll remember that somebody was there to help you out in getting placement. Okay. And I want you guys to be, super successful. Just crack the packages. It sounds impossible as of now. Okay, all the best, everybody. Bye bye. See you on the next live. But till then, I want that you do a dry run of it. You do a dry run of it. And there is also one problem which is happy numbers. You can try. You can try out happy numbers. A similar problem. Okay, bye bye, guys. Bye bye. I hope you enjoyed the things. So please explain that square root concept. Yeah, square root concept, the thing is that any number, any non-prime number, okay, any non-prime number will have multiple less than equals to the square root of n. I'm telling you again, just listen this very carefully. Any number which is a non-prime number. I'm taking an example. Let's say, give me any non-prime number. Let's say I'm taking 16, okay, which is not a prime number. So, any non-prime number will have a multiple less than or equals to the root n. Okay, root n. So here the n value is 16, which means this will have 16 will have multiple less than or equals to 4. That can be 2, that can be 4. So even if it have a multiple, except 1 or 16 itself, that time it will be a non-prime number. So we don't have to check this with other numbers like 8. If it is divisible by 2 and 4, automatically it's not a prime number. So why will check for the 8? We don't have to check, right? We don't have to check, because if it already have multiple more than 2, 1 and 16 itself, right? Like 2 and 4, so it's not a prime number. So we don't have to check again and again. Is it clear to you? Every non-prime number, I'm taking an example of, let's say, 8. So if you figure out the square root of 8, you'll see like 2 point something. But 2 is itself is a 2 is a multiple of 8, which means 8 is not a prime number. You're getting? You don't have to check for 4, right? You don't have to check. Even if it's have a single multiple other than 1 and number itself, it will not be a prime number. So every non-prime number have multiples less than or equal to the square root of that particular number. So to optimizing it, we are doing math.square root. Okay, either if you can run till n as well, but that will take a lot of time because that is not an optimized solution. Okay, okay, you got it. Okay, now we'll wrap. I hope you enjoyed this. Bye bye. Bye bye all. I'm going to wrap this. Bye bye all.